Hello everybody and welcome to Module 3. So we are looking again at describing our data in this module, and we're going to take a quick look at what we call measures of dispersion. And so our goals for this module include distinguishing among three definitions of the range of a set of data, computing the sum of squares of deviation scores using two methods. We're actually going to look at the main one. I need to change that. Compute the mean deviation of a set of numbers, calculate the variance of a set of numbers, determine the standard deviation from a given value of the variance for a variable, describe how measures of dispersion differ from measures of central tendency, and describe the role of measures of dispersion in summarizing data. Now, that probably sounds like I just spoke to you in some foreign language, but I promise you, in about 15 to 20 minutes, we're going to reevaluate these goals, re-examine them, I should say, and it will make sense to you. So let's talk about what we learned previously when we talked about central tendency. So central tendency is looking at how things gather around the middle in a set of numbers. We looked at three ways of measuring central tendency. The mean, probably the most common way, being the average is one way. It's typically what we mean of when we say average, the mean. But all of these can be described as describing the average. But the mean is the most common way. The median, the middle number, if we were to line them up and from least to greatest or greatest to least, we could line them up and look at the median. And then the mode is the most common seen number in our set of data. But this is not always the best way that we can get an idea of our data. So consider this hypothetical set of data here, and we're looking at class officers in a class, and I've listed some, the number of sit-ups they can do, and comparing that to the number of sit-ups cheerleaders can do in our class. And so if we look at our data, you can see here the class officers represented as 15, the vice president 22, the treasurer 28, the president 25, the secretary and the parliamentarian. But notice that all our cheerleaders, they can each do 27 sit-ups. And so what we find out now when we find our average, remember average or mean is denoted by X bar, an X with the bar over it. Our X bar, or our mean for each of these sets is, are you ready? 27. So the class officers do a mean number of sit-ups for 27, and the cheerleaders, the mean number of sit-ups they can do is also 27. But when we look at these data, we can see that this is not exactly a good description of the number of sit-ups individuals can do. Okay, so the average sit-up then for both groups is 27, but it's not equal if we take a closer look. So to help us understand a better way of describing data, instead of looking at central tendencies and looking at mean, median, and mode, we're going to look at dispersion of numbers. And we're going to look at four methods of describing dispersion. And dispersion here is saying how far apart are the actual numbers. And so we can see that's our concern here in this slide, is that the cheerleaders are all doing 27. There's no dispersion here. They're all the same. The class officers, we go all the way from a low of 15 to a high of 38. So that's what we're going to look at. And we're going to see that describing dispersion, measures of dispersion, is a better way to describe our data than simply looking at central tendency. So those four ways that we're going to look at are the range, the mean deviation, the variance, and the standard deviation. And so let us start by looking at the range. This is the easiest of them all. And so there are our data again. There are three ways of describing the range of data. The most common is the first method, and that is we simply report the smallest and largest numbers. Now we're looking at the range for X here. So the class officers. So our range according to method 1 would be the range of X is 15 to 38, meaning we had the small number of 15, a large number of 38. Our range for the cheerleaders would simply be 27. Okay? Method 2, we would subtract the smallest from the largest. And so we would come up with the range of X, our class officers, is 23, whereas the range of Y for our cheerleaders would be 0. So in that in and of itself, if we were to compare those two things, looking at the range by subtracting the smallest and largest, we would see that these numbers are really spread out, knowing that the mean is 27 of each. And finally, the last method here is just a technical method. You add 1 to the difference between the highest and lowest. And what this does is it actually gives the actual whole number value of the range that we are considering. So the range for the X, our class officers, would actually be 24, and the range for cheerleaders would be 1. In other words, we're saying that there is 1 slot available for cheerleaders, and we can look at our mean and see that that's 27. Okay. Our range for our class officers of 24 would mean that there are 23 slots between the lowest and the highest. Okay. So that's range. When I ask you to do range, I want you to do the first method, and we'll go from there. Okay. The second thing then is to look at what we call the mean deviation or the average deviation. And so this is really what we are wanting to ask ourselves. How far apart are they spread from the mean? And so you can see here we have 4 columns. And in our first column we've put our men, our class officers, not men, we don't know who they are. Our class officers' value for their sit-ups is X. We know that the mean is 27, so in our second column we have X minus X bar. That should be a complete X bar. I don't know why I just did a tiny piece, but X minus X bar. And then in our deviations, we're seeing how far apart each of them deviated from the mean. And then in the last column, we're going to look at absolute values, and we'll explain that in a second. So when we look at the mean deviation, so the first guy could do 15 sit-ups. We know the average sit-up was 27. So 15 minus 27, he deviated from the mean by 12 sit-ups. So we write that down as a minus 12. He deviated by 12. He was 12 below. The second class officer was able to do 22 sit-ups. 22 minus 27, X minus X bar. His deviation, or her deviation, was minus 5. In other words, they did 5 below the average, the mean. Our third one, 28. 28 minus 27 was a plus 1. This class officer actually did 1 more than the average, and so we have a plus 1. And so you can see as we go through until we get down to our last class officer, who was able to do 38 sit-ups. 38 minus our mean of 27. This person deviated by getting 11 above the mean. So if we look at the third column here in our deviations, we said that by attaching the minus and the negative, what we could do was determine whether they were below or above. But if we add these together, we get a total of 0. So you'll know you did it incorrectly if your deviation scores is something other than 0. Okay, so if everybody's either below or above the mean, and we take those negative and positive numbers and add them together, we get 0. Makes sense. So what we do then in this method to find the mean deviation is we simply take the absolute value. And so negative 12, the absolute value becomes 12. We add these together and get 38. And we take that total and divide it by our n, our number of subjects, which in this case is 6, and we get 6.33. So our mean deviation is 6.33. Okay, our average distance from the middle, from the mean number of sit-ups, was 6.33. Okay, so the mean deviation then of sit-ups is 6.33. The means, or this means the individual scores vary from the mean by 6.33 total. The closer to 0 this number is, the less variance in the scores there would be. So if our mean deviation were 1, that would mean that on average, every individual score was either 1 above or below the mean. And so in other words, they were crunched closer together. If our mean score was 12.33, the further apart they're spread, that means there's more variance. Okay, and by variance, we're talking about that difference in the distance to the average score. So we have to find the mean. We have to find the average as part of the central tendency. But we're going to take a next step and look at this measure of dispersion and describe how far apart things are from the average. Our cheerleaders, the mean deviation would be what? It would be 0. There was no deviation from the mean. Everybody had the same. So there is absolutely no variance in the number of sit-ups that our cheerleaders can do compared to that of our class officers. Okay, so you can see just by looking at mean deviation, what we've done is we have taken what we said the average was 27, the mean was 27. So it looked like the two sets were equal, but now we see if we look at just the mean deviation, the class officers had a mean deviation of 6.33 and the cheerleaders had a mean deviation of 0. Then that's telling us that the cheerleaders were not spread out at all. They were all exactly the same, while the class officers were slightly spread out. Okay, so the mean deviation is preferred to range in statistics, but it is not necessarily popular nor as useful as the last two things we're going to look at, the variance or the standard deviation. Okay, and so let's move into what we call variance. So the first thing that we're going to see on variance is this term sum of squares. Okay, we talked about deviation from the means. So these deviations from the means, the negative 12, negative 5, plus 1, minus 2. When we talk about term sum of squares, we're going to talk about these deviations. So just lock that in your mind. Whenever you hear sum of squares, it means deviation from the mean. And we're going to square it. Okay? So let's get back to this. So here are our sit-ups. I keep calling them, I use those interchangeably. Sit-ups and set-ups. To be honest, I don't know what it is. I guess it's sit-ups. Who knows? I'm sure somebody knows. Anyway, sum of squares. So in order to understand variance, we've got to start with that sum of squares. Now variance is really telling us how different our numbers are from each other. Okay, Okay, that's what variance means. How different are the data from each other that we're using? And so in order to get sum of squares, this is real easy. So here are the sit-ups again by the class officers. We need to find our little x. So we take x, the big X is the individual score, x minus x bar. X bar is our mean, our average, and that gives us our little x. Okay? And so we did this in the other. And when we added these together, the difference from the mean, we got 0. The sum of little x equals 0. Okay? Remember these notations we used in a previous video. But here what we're going to do is we're actually going to square them. So when we looked at the mean deviation, we simply took the absolute value. But here we want to square them. And the reason we're doing this is we've got to get away from this 0. That's not telling us the difference. But if we have a negative number, then we can square it. Okay? We can take absolute value, and there are videos out there that will explain the mean deviation and the absolute value, and why we prefer variance over mean deviation. That's a little bit out of the scope of this introductory course, but there are videos and information out there that explain that. So what we're going to do though is we're going to sum our scores, okay, or square our scores. So first person was 12 below the mean, square it, we get 144. We're going to do that for all our deviations from the mean. So now when we get sum of squares, so sum of x squared, we're just going to add up all these deviations. So that's what we mean when we say sum of squares. These are the square roots of all the deviations from the mean, and we're going to add them up, and we're going to get 344. So our sum of squares is 344. That's the first step in looking at what variance is. The next step then is to divide by our total number. So let's look at this first bullet here. Our sum of squares is 344. We're ready to find the variance. Variance is illustrated by the small Greek sigma. The big capital sigma is the sum. The small sigma squared is variance. So our formula becomes sigma squared, or just call this variance, is the sum of our squares divided by our n. So our sum of squares is 344, and we know our n is 6. We had 6 class officers, so our variance becomes 57.33. Okay, now that in and of itself doesn't tell us a whole lot. As I say in the next bullet, alone, this does not say much. What we could do would be compare two sets of numbers and find, if we were to find the variance in the second set is 25, we can say that the first set has more variance. The scores are spread out more. If we were to do the sum of squares for our cheerleaders, we would find out that our variance is 0. So now we can really see that our mean was 27 for both sets, but our variance for the class officers was 57.33, and our variance for the cheerleaders was 0. So this by itself tells us that the class officers' scores were spread out. The variance of our first set, our class officers, we would consider to be heterogeneous. They are different than each other, more heterogeneous. Okay, I don't know that we ever completely get to heterogeneous. We're just going to call them more different. The second set we would consider more homogeneous. Now, in the sense of our cheerleaders, we would, at that point, I think we would say they are completely homogeneous because our variance is 0. Okay. Figuring the variance. So this term sum of squares will be the basis a base that we use for the majority of the work in the rest of our class. Okay, so it is important to remember this idea of sum of squares and how we get it. So the last thing then that we look at for the measure of dispersion is the standard deviation. And standard deviation is the most widely used measure of dispersion by statisticians, and it follows right after the variance. You have to figure the variance first. Okay, so here we said that our variance equals the sum of squares over n. Our standard deviation is, notice that our formula now has just the sigma, it doesn't have sigma squared. What we've done is we've taken the square of both sides. So it is the square root of the sum of squares. X minus x bar is the same as saying little x bar squared. X minus x bar sum squared, same thing, over n. So really what we're doing to get to the standard deviation is we are taking the square root of our variance. So notice what we've done. Well, this is what I say. Notice what we've done is simply taken the variance and squared it. Our standard deviation for setups for the class officers is the square root of the variance, or the square root of 57.33, and we get a standard deviation of 7.57. Okay? So that is measures of dispersion. So let's look real quickly at what our goals were for this short lesson. So we have here our goals were to distinguish among the three definitions of the range for a set of data. And we said that we're going to use the first one as our preferred method, simply stating the range of x is, and give our lowest to highest. Compute the sum of squares of the deviation using two methods. I said we're just going to use one. So the sum of squares is looking at how much the individual scores vary from the mean. And then we're going to square that. And then we're going to add all those together, and that's our sum of squares. Compute the mean deviation of a set of numbers. The mean deviation used absolute value instead of sum of squares. Calculate the variance of a set of numbers. The difference between the mean deviation and the variance is that instead of using that absolute value and mean deviation, we actually squared our differences in variance and took that sum of squares and divided by n, our total number, and that gave us the variance. And then determine the standard deviation from a given value of the variance for a variable. So our standard deviation for class officers doing push-ups was 7.57. Our standard deviation for cheerleaders would have been 0 if you did the math. Okay. So again, there's no difference in the cheerleaders. The class officers, though, with the standard deviation of 7.57, we're going to talk about what that means in the next module. Okay. Our last two here describe how measures of dispersion differ from measures of central tendency. So measures of dispersion then really tell us how far apart the data are spread, whereas measures of central tendency tell us how close to the middle they are. Okay, and when it really gets down to it, once we know how close to the middle they are, then the most important thing is looking at how far apart they are. And then finally, describe the role of measures of dispersion in summarizing data. So let's look then at your assignment. We're going to talk about that measures of dispersion. So we're going to go back to our Module 0 data one more time, and we're going to find the range, the variance, and the standard deviation. Notice I left out the mean deviation. We're not going to deal with that. I wanted to just tell you what that was. But we're not going to deal with it because we're going to look mainly at variance and standard deviation as we move forward. Now remember what I said when looking at variance and standard deviation is the same thing. When we're interpreting the data, and of course I'm asking you to analyze and interpret the data, when we interpret the data, it's going to be difficult to say anything significant about the data here in interpreting it because we don't have two sets of data to compare to. But I want you to just give it a shot anyway at this point. I want you to get used to these two tasks that we're doing every time we look at data. Analyze and interpret, okay? So you're going to look at the height, pulse rate, and credit hours for semester, and you're going to find the range of each using the first method, the variance of each, and the standard deviation of each, okay? And make sure you understand that concept, sum of squares, and how that plays into variance and then ultimately standard deviation. Now, I know that Excel will do this for you, but I would encourage you to at least attempt one of these, if not all of them, by hand, simply because by doing it by hand, you're going to see what that sum of squares means. And so as we move forward in our course and we're talking about these things, especially when we get later in our course toward the end and we're referring back to them, by you doing these by hand, you're going to specifically understand what you're doing because you will have figured the sum of the square of the difference between the score and the mean for each of these, okay? Whereas if you just use Excel, you won't do it. You'll just be a passive learner at that point and get the data. But anyway, that will be your assignment. You will have one more short assignment coming up in this module that will appear in a few days, and it will finalize this first part of our course of just simply describing numbers. Whatever the numbers are that we have, whether it's using central tendency or measures of dispersion, at this point we're just describing our numbers.